Hello and welcome back to the channel. And today in Cyber Potato Show, I'm gonna show you another game for beginners using Unity 3D. And what you're seeing right now is, of course, the Unity editor. I am using the latest beta version, 2022. I have also created a first script that will be using only so that I can set up my windows properly. And today will be creating a Pong game. This is like the first game created ever, so it's a real classic, and I hope you are accustomed with that game. So basically what we have here are two paddles and a ball, some walls, a line, and a score. And of course, whenever the ball goes to left or right wall, given side scores a point. So your layout may be a little bit different, like this. I was just trying to find the one that would work for me, but we can stay with that layout. I'm gonna grab a game and maybe have it here. Okay, so basically what we'd like to do here is change the aspect of the camera to 16:9. That's already better. I'm also gonna click here and change the layout to a single one. And then I can, for example, grab my console and put it here. And that's way cleaner, I think. So you can drag and drop the windows inside of the Unity editor as you please. Okay, let's start figuring out that game. Basically, we need 4 walls to square off our playing field. So I'm gonna go and create new to the object, and that's gonna be a square. I'm gonna change the color to something grayish, and we have to position that. So maybe let's change the scale 0.5 and then start positioning those walls. 0.5, 0.25 would be good too. And let's start positioning those walls just close of the camera boundaries. So I'm gonna do minus 4.2. Looks like that. Then let's start scaling on the Y. So 20 is a little too big. 10 maybe. 10 looks fine. Let me actually drag it here. Okay, yeah, that changes the position of the camera as expected. Minus 8.6, 7, I'm guessing here, actually. Okay, it's 8.7. That's gonna be the left wall. Let's duplicate it by pressing Ctrl D, and then let's change to right wall. I'm gonna change the position to plus 8.7. Okay, duplicate it, and let's do top wall. So we could change the scale here and then give it a 10 here. So, or we could rotate, that would be fine too. Really. Just position this correctly. So well, minus 8.8 will be fine. It doesn't matter that we're a little bit outside of camera boundaries. Okay, let's position that here and here, and let's keep on scaling. So I can press R, just keep on scaling. That's a little bit too much. I'm not gonna go pixel perfect here. And I'm switching between scaling, rotating, and transform tools by using Q, W, E, R, T keyboards. Presses. Let's move it. Let's make it nice and round. 16 is to 18 should be fine. Okay, so that's our top wall. Let's duplicate it and let's rename it to bottom wall. And then let's bring it down to minus 4.87. And if we take a look at our camera right now, we have these wonderful walls. So we have border around our camera. Maybe just for fun, change the color of the left and right wall to be a little bit darker. This is 666, the number of the beast. Okay. Yeah, they're a little bit darker, and that's fine. But actually, so our ball will be bouncing around and bounce off of our top wall and bottom wall and off of our paddles. So let's create the ball, and it's gonna be easy. That's gonna be just a square. Let's call it ball, maybe capital B. Okay, and we can scale it to 0.25, and let's link the scale 0.25. No, it's linked. Okay. Okay, that's our ball. And then one last thing we need are paddles. And two of them, the player paddle and the enemy paddle. And what we'll try to do is we'll try to write some kind of simple AI that will control the enemy paddle. So let's create a square and let's call it paddle, and we're gonna make it green for our player and red for the enemy. And let's start scaling. I believe that should be 0.25 2 and maybe 2.5, and reset the Y transform, and let's put the starting position at minus 7.5. Okay, I'm gonna copy it and let's change the name actually to player paddle and the enemy paddle. Okay, and what do we need here? The position should be 7.5. That's fine. Change the color to red. Okay, cool. Basically, everything we need for our wonderful game. So let's start working with our ball. Let's save this. Okay, our ball. So basically, in the previous game, we were changing the transform position by ourselves. Uh, this time we can dive a little bit deeper into the physics engine and actually move our ball by applying some force to it. Right? If you remember from the math, right? If you remember from the math, if given object has a mass and you apply some force to it, then it means it also should have a velocity, and this is the velocity, right? And this is a vector, and this of course is a vector. So basically, if we want to get the velocity, we'll of course need the mass and the force, right? And this is a vector and this is a vector. Basic physics, I believe. So let's give our ball mass, and this is done by applying a rigid body. And if we start our game right now, of course, it will start falling down, and we don't really want to be affected by the gravity, and we don't want angular drag. Okay, so the ball stays in place. Actually, now is the right time to start coding, which is for me the most interesting part. So let's go to our ball script, and if we'd like for it to work, we will need to apply that script. So let's grab it and apply it to the ball game object. And we'll probably need the collider, but that's we can do this, but let's not actually for now. Okay, let's start coding. So here's the basic C# script for our game object generated by Unity. And what we need actually is the reference to the rigid body. We're going to create one, and this is going to be private rigid body 2D. And let's go, let's do with the underscore rigid body. And the speed, public float. I'm going to make it, I'm going to name it first. Okay, and let's use awake, and awake is being triggered once before the start. So this is a good place to actually get the references that you need. So let's get one, and I'm gonna use get component to get the reference to rigid body. Just to remind you, this this function is actually accessing the component that is living on a current game object. Okay, so we have the reference, and okay, this is fine. And I'm going to create two functions here that that I'm going to need. This is the reset position function and add starting force function. And the first function will reset the properties of the rigid body so that every time we start the ball, no matter if I'm moving it in my scene somewhere just to see it better or not, it will get positioned in the center. So it's gonna be rather simple. Let's generate that method, and that's gonna be actually I'm gonna make it public, and we have to reset rigid body position, and this is a vector of 3, so 0, and then rigid body velocity vector 3, 0. Okay, and then we have to apply the starting force. So it's gonna be public void at starting force, and what we have to create here are two variables x and y that will specify the vector of our force, right? Because as I mentioned before, the force contains is a vector actually. So you have to decide the x and y value, and I would like the ball every single time to behave a little bit different. So maybe when you're starting the game, right, and you have a ball, you'd like to apply some kind of random force to it. So maybe when you're starting the game for the first one, it's gonna go to the left, and the second time it's gonna go to the top left corner. So how can we do this? I'm gonna create float x, and I'm gonna do random value, random class system random value, and check whether it is less than 0.5. If it is, I'm going to apply the force that will push us to the left, otherwise the right. And it seems like, oh, I want to use the Unity engine random. So that's going to be a random value from 0 to 1, and that's like theoretically half a chance to apply the force to the left or to the right. Of course, it's random, so maybe 2 times it's going to be to the left, and then 3 times to the right. Then float y, and this is a little bit more complicated because here we're deciding where to go, up or down, but here we should also double the randomization, because we're not only want to decide upon the direction, we'd like to also decide randomly upon the applied force. So random value, the first check is pretty much the same, but then we're gonna use random range, and here we're gonna choose a value randomly from the range of minus -1 to minus 0.5, and do the same here, but in the opposite direction. And that should be, of course, random range. With that, we have the rigid body, add force, we create new force vector here, but we multiply that vector times speed. Okay. Well, yeah, and with that, I believe we don't need the update because the force applied to the rigid body will make our ball move. So let's try this right now. Okay, and let's run it again to see whether the direction of the ball movement will be changed. Yes, it does. Okay, great, wonderful. So we know that the ball should bounce off of um, the top and bottom wall, right? So let's create new folder here for materials, and we're gonna create something interesting here, and that's gonna be a physics material. So let's go to create, and then there's physics material, right? And I'm gonna call it bouncing material. Uh, and I'm gonna change the bounciness to, maybe let's try 1. Okay, I'm gonna take it and I'm gonna apply it to let's see, right wall, top wall. I believe this should have rigid bodies too. Let's try this. Yes, there's a material. Don't affect the gravity. What else? Let's try applying that. Let's see. There's none. Yeah, that may be because we need a physics material 2D. So let's go to create 2D, and here you will find the physics materials 2D. Remember that there's in Unity there's always this difference between 2D assets and 3D assets. So I'm gonna change the bounciness to 1. And now for the top wall, we can actually apply this, and here I'm gonna add the rigid body to the 2, and also we can apply and maybe change this to bouncing material. Okay, and our ball with it should have bouncing material too. So let's see that now. Uh, it's still not bouncing. That's not a problem. And we can do some stuff to fix this. First thing, I believe that we need box colliders, and that the physics material should be actually applying to box collider because, well, we'd like to bounce on collision. So let's remove the materials from the rigid bodies, add a box collider 2D, apply the bouncing material here. Okay, and probably also on our wonderful ball, we need a box collider 2 and apply the same material. Let's try now. And we can see that the wall, upon being hit, is starting to move. Not really what I wanted, so let's go here and change the body to static, and also here change it to static. And now we can see that the ball is bouncing off the bottom or top wall. So that's what we wanted. Let's try this again. Yep, we should be good with that. Okay, so next thing that we need is the player paddle and computer paddle and the way to control that. So let's start with the paddle. We will definitely need a box rigid body, sorry, here. And we would like to apply a little bit, let's change the mass to 0.5. We definitely would like to apply a little bit of drag, and basically what drag is like inertia. So it won't stop moving right after you stop pressing the button, just to make things a little bit interesting and of course harder for the player. Let's remove the angular drag and the gravity scale because we don't need those, and we will definitely need a box collider. And with that we should be done. You can leave everything by default. Let's apply the same components to our enemy. So 0.5 to 0 and 0, and the box collider. Okay, well, I believe that's the time we can start coding. So basically, when it comes to coding, stuff will be a little bit more complicated here. And that's because we'll create a base class from which we'll inherit. So basically, we have two paddles, right? And they share some similarities, but also they are different because that one is being controlled by the player, and that one is gonna be, let's call it AI, but that's an overstatement. So what we're gonna do when it comes to the class structure, we're gonna create base class paddle, and we're gonna inherit from that and create enemy paddle and player paddle. Okay, so let's get going. We're gonna create new script, and that's gonna be a paddle. And since we're here already, let's create enemy, enemy paddle, and let's create player paddle. Player paddle. Okay, and with that, we can start coding. So here in the Solution Explorer, we can get to our scripts too, and we're going to start with the paddle. Not a lot here, actually. We're going to need the awake method. We're going to need speed, so let's create that as a public field. Okay, and then I will need the reference to the rigid body. And I'm going to use that class property in that script and in the scripts that are inheriting from the paddle class. But I don't want it to be visible to the other classes and the outside world. So if you want to have a property that can be inherited, but it's still encapsulated within those classes, the main class and the classes that are inheriting from given class, you use the protected access modifier. So here I'm going to create the reference rigid. Let's make it with underscore to rigid body to D, and we get the component with the rigid body to D. And then I'm gonna also create a public method called reset position, because every time we score a point and we're moving up and down, I would like our paddle to get back to the starting position, which should be 0. So basically that's going to be a new vector, and current x position should be maintained, so it's x, and reset the y to 0. Wonderful. Then we can work on controlling the player paddle. So let's open that script. Okay. And here we're gonna have a direction. It's gonna be up or down. So vector2 direction. We don't need the start, but we'll need update. And here we'll decide upon the direction. So float vertical axis value is going to be input get axis vertical, and we're not moving in the horizontal axis, so that's enough for us to move. Vertical axis value can be greater than 0, which will make the direction up. Less than 0, vertical axis less than 0, and then direction is going to be vector2 down, or else the direction is going to be vector2 0, and we have to use double quotation mark in C#. That's not JavaScript. Okay, so this is the update where we're reading the input, and then we should apply the force to our rigid body, since we're leaving the movement of our game objects to the physics engine. And we shouldn't really do this in the update. Actually, when you're working with physics engines, the updates that relate to physics engine should be applied in the fixed update method. And here I can check the direction, and I have to check whether it's not 0, right? So basically I can do something like square magnitude, or actually I could check whether it's not equal to vector2 0. That should work too. I should do rigid body, and I don't have the access to rigid body, right? Because it's declared in the paddle. So to get the access to that, I should actually extend the paddle, inherit from paddle class. And now I have access to that protected field. Basic Programming 101. And then we can apply the direction times speed. And that should be it for our player paddle movement. So let's get that script and let's apply it here. I can see it being applied, so let's see whether we can move it. Okay, not something I expected. Let's try again. Okay, again, no luck. Okay, well, we're moving. It's fine. Let's see whether we can. Okay, that's the second time that happened. I'm just to let's decrease the speed of the ball. Let's do a half of that. Okay, well, not the perfect collision. So probably what we also have to change here is how our paddle behaves. And to do that, we have to change our collider a little bit. So we have to change the box collider on our player paddle to is trigger. And then I'm going to create another script and call it bouncing. Okay, that's fine. And actually, we can go to our player paddle and to rigid body and find the constraints and freeze the position in X and freeze the rotation. Actually, uncheck that and see how that behaves right now. Okay, no lag there. So maybe instead let's add those and let's code our enemy paddle and let's force it to move. So that's gonna be enemy paddle. And what we'll need here is the reference to the ball. So let's do serialize field private rigid body to the ball, and the only thing we need here is the fixed update. Okay, and we'll be behaving differently depending on the direction in which ball is moving. So if the ball is moving towards the enemy, we'll try to position our middle point at the height of the ball. So in that example, if the ball is here, we have to move up. And if the ball is moving towards the player, the best position to take actually is to move to the middle. Is the like safest position to defend ourselves, to defend for the AI, right? So if the velocity of the ball is bigger than 0, we'll try to track its middle, otherwise go to the center point of the y-axis. So let's do just that. We'll be checking for the ball velocity. Here we have our if-else statement. ball velocity x, sorry. Okay, and check if ball position dot y is equal, then transform position y. So if the position of the ball on the y-axis is greater than the position of the enemy paddle on the y-axis, then the rigid body, we have to inherit from the paddle. Rigid body 2D, add force, that's going to be vector to up, so move up times speed. Else, if ball position y is less than transform position y, reach body to D, add force vector to down times speed. Okay, so depending on the position of the ball on the y-axis, will move either up or down in case the ball is coming towards the enemy paddle. Here we will handle the case of enemy moving towards us, towards the player, right? So since here the velocity is less than 0, so if transform position is greater than 0, and that would mean we're here, because here is the y-axis and here we have the position greater than 0. We should be moving down. So each body add force vector to down times speed. Else, if transform position y is less than 0, reach body to D, add force vector to up times speed. And we should check for the y, of course, here. Okay, let's see. No errors. Let's see where we can track the ball correctly. We could if we only apply the script. Let's try that again. Okay. Bouncing, and oh yeah, we forgot the reference to the ball. Common mistake. That means that we have a field here that should be provided with a value, and now we have that. So now our script has something to track. Okay. And I failed there, and that's a point for the enemy. Okay, as you can see, it's trying to track. No, unfortunately, our ball is stuck, but we'll fix that. We have that bouncing script right here. And what we'll do is on each collision, we will basically speed the ball up. That's the idea. So what I'm going to do here is I'm going to create a field called bounce string. Okay. And I'm going to use on collision enter to D here. And we have to basically get the reference to the ball. So collision game object get component, and that's going to be the ball, because that's what's colliding. But just to be sure, we can check for that. And then we can create a normal. And if you don't know what normal is, right, this is the vector that is pointing, that is perpendicular to a given object, meaning if we take a look at our paddle, and if the ball is coming from that position, right, then probably the normal will be like that, I suppose. Maybe like that? Not really sure. But we'd like to create the opposite force whenever the collision is detected. So we have, let me get back to the code. So we have our normal, then we can just do ball at starting force minus normal, because we would like the force to go to the opposite side, times bounce strength. Sorry, add force. And it seems we don't have that, so let's add that function. That's going to be very easy. Public void add force. It's going to be vector to force rigid body add force. And let's check for errors, especially in the bouncing. Okay, then there's a question, where should we apply our bouncing scripts? I believe that the top wall and the bottom wall and our paddles are good. So enemy paddle, player paddle, top wall, bottom wall. See how it behaves now? Okay, I missed. Okay. As you can see, the enemy paddle is trying to track us, and this is way too slow. We can click on the ball and check whether the I didn't expect that. Whether the velocity is changing every time it bounces. Okay, there's this strange case when our ball is moving up and down. So maybe we can fix that. That's the ball. Maybe we shouldn't check for vector 0 here, but rather the square magnitude. No, not that. Well, I believe we're missing the bounce strength on our bouncing script. So let's apply something like 5, 5. Let's make it 10 and 10 for the paddles. And I hope, nope, we're still having that problem. Okay, so there are a few things we have to do to fix this. First thing, we can remove rigid bodies from the walls. They're not going to be needed. We can remove the bouncing materials from the walls. And then the most important one, go to our ball and change the location of the physics material to be on the rigid body. And finally, go to the bouncing material and remove the friction. And that's gonna allow the ball to actually bounce off of the walls correctly. So yeah, basically we have what it takes to play the game, but there are a few parts still missing, as you can imagine. So we're still missing a few points. One thing I would like to add here is a line in the middle separating the enemy's field side and the players. So we can do that by going to 2D sprites and what we're looking for is line renderer. Or we can do better, we can do empty, call it line, reset the transform to the middle, add component line renderer, and basically we have to change some stuff, positions to, if we're gonna stretch it from -10 to 10, as you can see, the line renderer is actually taking the whole height of the screen, and that's good. But we have to change the width to something like that, or we can even make it more precise by scrolling there. Can do 0.1. Okay, and the problem is that I would like to make that line dashed. So for that, I'm gonna need a new material. I'm gonna create material and call it dashed mat for material, and we'll have to change it from standard to where is it? Unlit, I believe. Yes, that's correct. And we'll need a texture for that. And that's actually interesting one because that was the first time I worked with the graphics. And let me show you what I've done to achieve this result. So I used pixel graphics software, Sprite, but you can do it in Paint, or you can do it in Photoshop or Pixel Editor. And basically what we have here is 8 by 8 square with the 4 inner pixels filled with the white color. So let me bring that to the assets. I'm going to create new folder and call it sprites. And here we have it. Do we need to change? We need to change the wrap mode to repeat, and we need to change the filter to point no filter and apply. Then I can take this sprite that we just changed and apply it to our material. Okay, looking good. And then finally, in my line renderer, and I hope that works, I can find, there should be material. Oh, here it is. I can drag and drop it here. And as you can see now, this is still a line, but if I change the texture mode from sketch to tile, it's not any better. And what are we missing here? And the thing that we're missing is actually we have to change the shader to take the transparency into account, so that's UI unity transparent, and now we have our dotted line also in the game. So that's done. The next point is about handling the score in our game. So basically, whenever we hit that left or right wall, we would like to score. So what I'm going to do is I'm going to create new script. I'm going to create name it 4. And let's open that up. Okay. So here we're gonna basically check for collision on collision enter 2D, and whenever it happens and the collision is caused by a ball, we then should inform our game that it should increase the score, right? So let's actually create another script that will handle the score display. So I'm going to create score display script, and I'm going to create an empty to which I will attach that script, and let's call it score counter. Okay, score counter is a better name, so let's change it here. Score counter. And let's just apply it. Yeah, I renamed that, so I also have to rename that here for it to match score counter. Now we should be good. So apply that here, and in the score counter we'll need a few things. actually, and that's gonna be, let's start with private int player score, private int enemy score. And let's create two public functions here. Player scored and public void enemy scored. Okay, with that we can increase the player score and enemy score respectively. And let's debug log this. So player score or debug log enemy score. Okay, and now the problem is, oops, I didn't want to detach that window. Whenever the ball hits the wall, would like to inform our game that something happened. And actually there are many ways to do this. We could, for example, pass the reference here, pass the reference of the score counter to that class. But there's other way. Basically, you can broadcast about the event happening in the game with the event system. So I'm going to create a trigger for the event system, and this is basically like announcing to your whole game that, hey, something happened, and then given elements can react to that. So we're going to create a trigger, and then we will invoke that trigger, and you have to pass some data in here. For that one, it's not relevant what that is because it's a complicated subject. Event system current. Okay, and pass it here. And now with that, we can go to our score and attach it to the right wall and the left wall. And as you see right here, under my score script, I have the base event data for the event system. And here I can tell what function should be triggered whenever this event is being broadcasted to the game. So here I can find my score counter, and this is for the right wall, and that means that the score counter, oh sorry, I should bring that here. And now I can find the information about the player scoring because that's the right wall. The same should happen for the left wall. So let's click plus here. Let's bring the score counter object. Let's find the enemy scored. Okay. And that should allow us to display the info about, well, at least one person scoring. So let's try that. Now we should get the information about the enemy scoring. So let's try that again. Did I right wall, left wall, score counter? And that's because, of course, we didn't attach the box colliders to the left and the right walls. So let's try that again. And we'll let the enemy score. And now we have the information about the fact that someone scored, and the points are displayed here. Great. So with that, we can actually add a simple UI. So let's go to UI, legacy system for now, and let's do the text. We're gonna do the player score, and we're gonna do the UI legacy text enemy score. I'm gonna change one thing here. I'm gonna add a font. So let's create new folder to keep everything organized. And that's the Fauti free to free regular font. If you'd like to find it, just go to the Google fonts and you can search for the Fauti free to free. It's pixelated and it looks really nice when it comes to these retro games. So we have that. I'm gonna use that font here and here. Let's go to our canvas and let's set the correct placement. So I'm gonna take the enemy score and I'm gonna anchor it here. I'm gonna take my score, go to anchor presets and anchor it here. Then let's change we need the height to be bigger. Where is it? Something like 250 by 125 should be good. Same here. 250 to 125. Let's reset the anchor. Do the same here. Okay. And now the font size and font color. Font color should be white in both cases. Font size here, and let's set it to the middle. That's 70. Let's do the same here. Anchor it to the right, middle. Okay. Starting text is 0 and starting text is 0 here. Maybe we could offset this a little bit to the left and right. So let's do 150 maybe, and here minus 150. Okay, a little bit better. Then we have to actually update the text for our UI. So how can we do this? We actually can keep the reference in our score counter. Yep, and basically I don't want to call this scoring zone. Let's refactor this a little bit. There's the score, right? And everything that is happening on score. Okay. So let's add a script to our canvas. Should we or should we not? Okay, let's start by adding the score to our um, paddles. Now I'm thinking where we should, well, let's definitely add it to our ball, right? And here we can actually reference ourselves. Or maybe not, maybe we can do it smarter. So there's a score counter, there's the wall, there's the right wall, and there's the left wall. So basically we can add more things that should happen here. So let's grab the ball here, and on the ball we can do reset position, because whenever we score we should reset the position, and add starting force. So again, grab our ball and let's do add starting force. Okay, that's one thing. Then we should also do the another things we should do whenever someone scores. So that's the right wall, is to reset the position of the paddle. So let's grab the player paddle and let's see, let's reset the position, and another one, and let's grab the enemy paddle and reset the position. Okay, and same should go for the left wall. So grab the ball, reset position, and add starting force, take the player paddle and reset position, take the enemy paddle. You have a typo here, not a problem, and reset position. Okay, so, and we should save that. So these are all the things that should happen whenever someone scores. Almost everything. So let's try that. Okay, great. Everything resets. The one thing we should do is to also update the text for our UI. So I'm gonna create a new script here, and I'm gonna call it UI. I will attach it to the canvas. Something is reloading. Let's give him a second. Okay. And now what we can do is to create the references to the text. So let's get rid of that. And basically you have score counter here. So we're already calling that. So yeah, we're going to create a public text enemy text. Okay, let's import the UI engine. So Unity engine UI, you have enemy text and public text player. Let's do enemy score text player score text. And what we'll do is we're gonna do update. We're gonna do public void update enemy score text score will be int score. We're gonna do enemy score text equals score to string. The same for a player. So player update player score text score and enemy score text is going to be equal to score to string. Great, and with that, in our score counter, we can reference our UI. So that's going to be serialized field a private UI. Don't need that semicolon. Here we're gonna go update player score text and pass the player score, and here we're gonna do UI update enemy score text and pass enemy score. The last thing that we'll need is actually to go to our score counter and pass the UI, which is attached to the canvas. And then we need the references to the player score text and enemy score text. And with that, I believe we're ready to go. Let's check that. Yep. And we have pretty well playing Pong game. Let's allow him to score again. Great, so it wasn't with a few problems, but we made it through. And next game created in Unity is done. I hope you enjoyed it. I plan to do definitely more retro games in Unity because, to be honest, writing the React code for 8 years now become a little bit boring, and I now feel like learning something else, which is really refreshing for me. So that's that. I hope you enjoyed it. Please comment, like, and subscribe if you will. And I'm going to see you in the next episode. Goodbye.